take a look at 3.3 part 2. So we've already learned two different groups of identities. The first group we learned was the reciprocal, which usually has something to do with like 1 over and flipping it. And then we learned the quotient identities. Sine over cosine is tangent. Cosine over sine is cotangent. The last group of identities we're going to look at are called the Pythagorean identities. Yeah, I'm going to show you an example of the first one with numbers, and then I'll write out what the identity is. So, Ava, can you give me an angle? Any angle you want.
60.
60. Okay. So she said 60. So what I'm going to do is I'm going to take, I'll just put it in degrees. This doesn't matter. I'll put it in degrees. I'm going to take the sine of 60, and I'm going to square it. And I'm going to add the cosine of 60, and I'm going to square it. So I took the angle, took the sine of the angle, squared it, took the cosine of the angle, squared it, add them up, and I got 1. Let's try another angle. Maybe 60 was special. What's another angle? Oh, Pete, you need another angle?
An angle?
Yeah.
90.
90?
Yeah.
You sure?
That's the neatest one I can think of.
Okay. So we've got sine of 90. We're going to square it. We'll take the cosine of 90, square it, add them up. I get 1 again. You're always going to get 1. Doesn't matter what angle you use. That's our first Pythagorean identity. We take the sine of an angle and square it. Take the cosine of an angle, square it, add them up. The answer will always come out to 1. So that's nice because anytime we do a problem and we end up with sine squared plus cosine squared in the problem, we can cross that whole thing out and replace sine squared plus cosine squared with a 1. And the reason it's called the Pythagorean identity is because if you look at it, it kind of looks like something you'd see in the Pythagorean theorem. Usually Pythagorean theorem has something squared plus something squared. And that's kind of what we have here. Something squared plus something squared. All right, let's look at our second one. So the second Pythagorean identity is 1 plus cotangent squared equals cosecant squared. Again, you don't have to memorize them. It just helps to recognize them. So when you do a problem and you see a lot of things with an exponent of 2 in the problem, you're probably going to have something to do with a Pythagorean identity. Okay. We didn't have a ton of problems yesterday that had exponents of 2 because we didn't have these identities. Okay. And the third one uses the 2 trig functions we haven't used yet, tangent squared and secant squared. And it says tangent squared plus 1 equals secant squared. Okay, so those are the 3 Pythagorean identities. At this point, I've given you all the identities that you're going to learn. The reciprocal, the quotient, and the Pythagorean. Yes?
Is there a reason that that's 1 plus cotangent and that's tangent plus 1?
No, you can write them in different orders. That's what I was going to talk about right now. So let's take the second one. And let me go like this. I'm going to minus cotangent squared from the left, and I'm going to minus it from the right. If I do it on the left, this part disappears. Now it says 1 equals cosecant squared minus cotangent squared. That's the same identity that I just had. It's just rearranged. Okay? So I'm not going to write every identity every single way, but you can rearrange these identities. Okay? Same thing with this top one. you could move cosine squared to the other side by subtracting it. And then you'd have sine squared equals, and if you subtracted that, it would be 1 minus cosine squared. Same idea as that distance equals rate times time we talked about. You can rearrange it, and it's still the same formula, just rearranged. Okay. So any questions on that idea of rearranging? All right. So this is what I explained to you yesterday in the email. I said that when you're asked to verify an identity, verify is like the worksheet from last night. You're going to be given the left-hand side. You're going to be given the right-hand side. The goal is to work with the left-hand side and keep simplifying it until you end up with what's on the right-hand side. So verify is kind of nice because at least you know where to start and you know where to stop. Compared to a problem that says simplify, that's open-ended. They give you a problem, and with simplify, you just keep going till you think you're done. But you never really know you're done. Okay, with verify, you know you're done. And that's what you'll expect to see on the worksheet for tomorrow and on the test. It'll be more like verify. Now, generally, when you do a verify problem, you always want to start with the side that looks more complicated. It's a lot easier to take something that's complicated and make it look simpler than to take something that's already simple and make it more complicated. And that's why every problem in the homework, I always put the more complicated side on the left and the simpler version of it on the right. It's usually pretty clear which side is more complicated. All right, so in a second, I'll just click through all the problems for today, and we'll be able to quickly see, or I'll point out to you, which side I think is more complicated. All right, so if I look at that first one, or the second one, I would say here, the left side is definitely more complicated than the right. Again, left side, way more complicated than the right. Left side is more complicated. Okay, it's usually somewhat clear. But I usually just put the more complicated side on the left anyway. All right. I don't think I asked you about this one, but which side looks more complicated here, the left or the right? The left. The left has 3 different trig functions. It has multiplication, subtraction. The right is a single trig function squared. So our goal is to simplify the left-hand side until it turns into the right. Now, you can still use all the identities we learned yesterday in addition to the 3 that I showed you today. Doesn't mean these are going to come up now in every single problem we do. They didn't come up in any of the problems from the homework last night. You might still have some on the test that don't use these, but you'll have some that do. Okay. All right. Any thoughts about what we should try on the left-hand side first? That's what LHS is. We're going to work with the left-hand side. Even if you're not sure how that would help you, don't maybe worry about how it's going to help you yet. Just try one of the 3 tricks I taught you and see what happens. Yep?
Change cosecant to 1 over sine.
Yeah, let's change cosecant to 1 over sine. So we have sine. I'm just going to keep that with the denominator of 1. Cosecant is 1 over sine. And let's keep the cosine squared the same. Okay, I'm only writing down the left-hand side. The right-hand side is just there to tell me this is the answer you're supposed to end up with. So we're just going to leave that over there. But let's work with the left-hand side. All right. How many terms do I have written down in blue? Remember what I said, terms are separated by. Yep, there are two. This is the first term. Okay. That's the second term. If you have any terms that have the same thing in the top and the bottom, you can cancel it. So, is there anything that would cancel here from the first term? James?
Both the sign and 1.
Yeah, the signs, those we cancel out. And what is 1 divided by 1? 1. So now I have 1 minus cosine squared. Does that kind of look like anything we talked about? Yeah?
A little bit like the first Pythagorean identity we talked about.
It is. It looks kind of like the first Pythagorean identity. Let's go back to that. The first Pythagorean identity is sine squared plus cosine squared equals 1. Okay? So let's just write that down off to the side again. Sine squared plus cosine squared equals 1. What could I do to that to make it look more like what I have? I'd have to rearrange or I'd have to move something. Anybody see what I could do on both sides? And if I do that, then this identity will look a little bit more like what I have. Yeah.
You subtract the cosine squared of angle and minus 1.
Yeah, so let's subtract cosine squared from both sides. And if I subtract it from the left, it cancels out. And I subtract it from the right, I have 1 minus cosine squared. What does that equation say 1 minus cosine squared equals? What's on the left? Yeah.
Sine squared over angle.
Pythagorean identity number 1 says that 1 minus cosine squared will equal sine squared. So I can change this to sine squared. That's Pythagorean identity number 1. That's the reason why. Now let's scroll back up and see if that's what they had on the right-hand side, then we're done. They wanted you to get sine squared, and we did. So it involved using a reciprocal identity, canceling, and then recognizing that what you had was really a Pythagorean identity, just rearranged. Okay, any questions on that one? All right, let's try another one. Let's try this one. So that's sine times cotangent plus tangent. And somehow that is supposed to equal secant. So when I'm done messing around with the left-hand side, if I can turn that into secant, then I know I've finished the problem. So the answer here is really your work. You're showing me how this turns into that. Okay. Any thoughts about what I should try first? Yep.
Distribute.
Yeah, I would say this looks like a pretty classic distributing problem because you have something on the outside and you have a term and a term. So let's multiply sine to each term. All right, so it's going to give me sine times cotangent. Copy down your plus, and then sine times tangent. Okay. What could I do now? Yeah.
Could you turn the cotangent and tangent into their simpler form using their sine over cosine, cosine over sine?
Yeah, I want to change those to sines and cosines. My hope is something's going to cancel out. We'll see what happens. So let's keep sine the same. And let's keep sine the same. What's cotangent? How can we rewrite that with sines and cosines? Yep. That's cosine over sine. And what about tangent? What's that? Yeah.
Sine over cosine.
Sine over cosine. Just to be clear, there are two terms on the board there. Terms are separated with a plus or a minus sign. You can cancel from a term anything that's in the top and in the bottom. That's a term. That's a separate term that has nothing to do with the first term. So you can't cancel sine from the bottom here with sine in the top there. No, you're canceling across a plus sign. You can't do that. You can only cancel across the multiplication sign. So, is there anything in the first term that would cancel out? Raymond?
Sines.
Cancel the signs. So now I'm left with cosine in the top, and I'm left with a 1 in the bottom. All right. And on the right, I don't see anything that's going to cancel. So we're just going to have to multiply it out. James, what's sine times sine?
Sine squared.
Sine squared. And what's 1 times cosine? Cosine. So now that we've done that, let's scroll back up and look at the problem and see, is that the final answer that they wanted? No. They want us to get secant. That's not secant. So we gotta keep going. All right, we did the distributive property. We changed to sines and cosines. What's one other trick that we learned yesterday, and I don't think we went over one in the homework. Yeah?
The common denominator.
Find a common denominator. Yeah. And just because I've done a lot of identities, I'm looking at this and I'm seeing this, sine squared. So I'm thinking eventually this might be involved somehow. What I don't see right now is cosine squared. I only see sine squared. So let's keep an eye out and see if cosine squared all of a sudden pops up somehow. All right. So remember, easiest way to find the common denominator is to multiply the two that you have together. All right. What do I get if I multiply 1 times cosine? Yes? Cosine. The fraction on the right already has a denominator of cosine, so I don't need to change that one. Okay, it's fine. So let's leave that. But what would I have to multiply top and bottom by in this fraction so that I have a common denominator? Yep, cosine. Multiplying the bottom, multiplying the top. Cosine times 1 is cosine. So now this fraction has the common denominator. What's cosine times cosine? Yep. Cosine squared. Well, now I see cosine squared plus sine squared. What is cosine squared plus sine squared? Yeah. 1. I know it's in a different order, but addition, the order doesn't matter. Cosine squared plus sine squared, that's the same as sine squared plus cosine squared. 2 plus 5, 5 plus 2. Still the same thing. So cosine squared plus sine squared is 1. So that entire numerator turns into a 1. So now we just have 1 over cosine. And what do you get for a trig function when you flip the cosine? Yep, you get secant. So now, let's scroll back up, and if secant is what was on the right-hand side, then we're done. If not, then we're stuck, because I don't know what else you're going to do with that. It's a single trig function. There's nothing left to do. So that's got to be the answer. And it is. Secant. All right, so that was a little bit harder. So it involved a distributive property, change to sines and cosines. Then we found a common denominator, which gave us a Pythagorean identity. So that one really had like four steps in it. Okay, any question on that one? Yeah.
When you do the common denominator, do you only multiply to the first term?
In this case, yes, because whenever you're trying to find a common denominator with a 1, you can always just use the other denominator as your common one. So like if I had to add, let's say 3 over 1 plus 5 over 7, the common denominator is just 7. So I wouldn't have to multiply anything here. I would only have to do the 7 there. Okay, so anytime you have a fraction that has a denominator of 1, just use the other denominator as the common. Yep. All right. Let's look at this one. So it's tangent plus cotangent over secant times cosecant. All right, let's see how we're going to do this one. So there's lots of ways, especially when we start getting to an identity like this, there's lots of ways you can start it. Our goal is to find the simplest way, which I'm not sure what that is. So we're just going to have to start doing the problem. And then if I notice that as we do it, it's getting worse and worse and worse, and it's not getting where we want to go, then we'll take a step back and we'll try something different. All right. But for this one, I would work with the top first. That's my thought. So we'll leave the bottom the same for as long as we can. And let's see if we can simplify the top somehow. All right, so let's start with tangent. What can you rewrite tangent as? Jacob?
Sine over cosine.
We can write it as sine over cosine. And what about cotangent? Yes. We can write that as cosine over sine. Now, just by doing that, I instantly saw what's going to happen. Okay, I didn't see it before we did that, but now it's like it just all of a sudden it just clicked and like 6 steps just popped into my head. Again, it's just because I've had a lot of practice. Okay, but as you see more, you get better as well. The bottom, I'm just going to keep the same. I'm not going to change that at all. So let's just keep it as secant times cosecant, and we'll see what happens. If you changed it to sines and cosines, I'm sure there's a way you could get it done with that as well. All right, well, let's try this. Okay, can I cancel the cosine in the bottom here with the cosine in the top there? Yep.
I don't think so.
Now, you're trying to cancel across a plus sign. You cannot cancel across a plus or a minus sign. All right, so in the top we have 2 fractions that have different denominators. Let's add them together by finding a common denominator and see what happens. Again, bottom is just going to keep the same. And maybe at some point I will need to change the bottom. Depends how we go about solving it. But for now, let's just keep it the same. What's my common denominator for the two fractions I have in the top? So use that same strategy you'd use to find a common denominator if it was just numbers. And do it exactly the same way. Yep.
Which common denominator?
Just a common denominator, that's fine. Preferably least common denominator, but any common denominator is fine.
It'd be the one on the left, it'd be sine, and the one on the right would be cosine.
So your common denominator down here is going to be what times what?
Sine times cosine.
Sine times cosine, or cosine times sine. Common denominator is the product of the two that you already have. Right? Cosine times sine. So cosine times sine. Now let's see what's missing. What's missing from the denominator on the left to make it the common denominator? Yes? Sine. So you're going to have to multiply top and bottom by sine. What's missing from the denominator on the right to make it the common denominator? Yep.
Cosine?
Cosine. So you end up multiplying each fraction by the other denominator. That's how it works with numbers. It works exactly the same way with this. Cosine over cosine. All right, so sine times cosine, that's what I have in the bottom already. Sine times cosine, again, that's what I already have in the bottom. Now, what's sine times sine? That gives me sine squared. And what's cosine times cosine? Yep.
Cosine squared.
Cosine squared. All right, and now there's something there that we can recognize from that last step. Anybody recognize something that's going to simplify a lot? Okay?
This sine squared plus cosine squared is will become 1.
Becomes 1. So that entire numerator becomes 1. Now, if you want, you can write it like this. We're going to have a 1 in the top. All that's going to disappear. If I do that, is that the same thing as just putting a 1 in the middle like that? What do you think? Putting that 1 in the middle compared to doing something like that. Jacob, what do you think? Yeah, because if I multiplied these together, I'd have 1 times 1, so I'd have 1 in the top, and I'd have cosine times sine, and that's exactly what's in the bottom. So when that top turns into a 1, I can write it just like that. What's in the bottom is still staying right where it is. Secant times cosecant. But look at what's going to happen here. What is 1 divided by cosine? Yep. Secant. What's 1 divided by sine? Yeah. Cosecant. over cosine is secant. 1 over sine is cosecant. That's the top. Look at what you have at the bottom. Secant times cosecant. Is there anything there that's in both the top and the bottom? Yes? Both. You have a secant in the top, secant in the bottom, cosecant in the top, cosecant in the bottom. So when everything cancels out, what does that mean you're left with in your fraction? Yeah. 1. It's like when you divide two things that are the same. Like if you had 8 divided by 8, the answer would be 1. You're dividing two things that are the same, you get 1. Now, at this point, if that's not the answer, then we're in trouble. Because there's nothing else you're going to be able to do with that number. So let's go back up. And that's exactly what they said we should have gotten. Okay, so in terms of like difficulty, that's probably one of the hardest ones we've done. Okay, and on the test, there wouldn't be anything any harder than that. That would be as hard as it gets. Now, if you said, well, you told us to always try changing things to sines and cosines. So if you change this and this to sines and cosines right away, you could have still done it. I don't know if it would have been easier, harder, I'm not sure. Okay. But that one probably took about maybe 5 steps. All right, let's see what else. Okay, let's try this one. Does anybody remember what these things are called? Cosecant minus 1, cosecant plus 1. There's a name for those. It begins with a C. Yeah? They're conjugates. So this is something that anytime you see conjugates, FOIL them out. Always. No matter what. Okay? If you see conjugates, FOIL them out. That even overrules changing things to sines and cosines. Because anytime you take two conjugates and FOIL them out, stuff always cancels. And it's always good to cancel stuff out first. So if you were thinking, oh, cosecant, I can change that to 1 over sine, this is going to get really messy if you do that. So when you see conjugates, FOIL them out as the first thing you do. Always. And sometimes the problem is done very quick. This problem will be done in 2 steps if you FOIL conjugates. Okay. Let's start with that. What's cosecant times cosecant? Yep. Cosecant squared. All right. Now, normally I don't write this part down, but we can just write it. What's cosecant times 1? How about James?
Cosecant times 1.
Cosecant? What's cosecant times negative 1? Negative cosecant. And negative 1 times positive 1 is negative 1. Remember that right-hand side is just there to tell you that's the answer. So we're not really worried about writing it down. Let's just work with the left. Now, there are 4 terms here. These are my terms. 1, 2, 3, 4. Those are all separated by addition and subtraction signs. Is there any terms there that cancel each other out? Pete?
Cosecant and negative cosecant.
Right. When you have terms that are opposites, that's like doing a +6 and a -6. It comes out to 0. So term 2 and term 3 disappear completely. So all we're left with now is cosecant squared minus 1. At this point, that's something that you have to recognize. Let's go back. Okay, just remember what that looks like. Cosecant squared minus 1. And does cosecant squared minus 1 look like anything that's up there? Yep. It is. It's the second identity. what would you do to this to make it look like what we have?
Minus 1.
-1 from both sides. If you -1 from here, that's gone. And if you -1 from here, now you have this. This formula says that cosecant squared -1 automatically turns into cotangent squared. So cosecant squared -1 turns into cotangent squared. All right, let's write that down. I changed cosecant squared -1 into cotangent squared using the Pythagorean identity. Now, at this point, there's nothing else to do. Okay, I just have a single trig function. So if that's not the answer, then I don't know what else to try. Let's go back up. That's exactly what they wanted us to get. Okay, so by foiling out the conjugates, we really finished that problem in 2 steps. Changing to sines and cosines, this would get really bad. Doable, but it would be a lot worse. Okay, any question on that one? Yes?
If we were to do this in a test, we have to put the -1 and the +1.
The -1 and the +1. Can you, I'm not sure what you mean.
So like, when I worked on the note, it was like 1 plus cotangent squared equals cosecant theta.
1 plus cotangent squared. Yes, that's what it was originally. Yep. It looked like this.
Oh, okay.
So what we did is we rearranged it
Oh.
to make it look like what we had. There's 3 ways to rearrange each one of these. You can have this by itself, or that by itself. Just like distance equals rate times time. There's 3 ways you can write that formula. All right, I think we have one more. Yep. Okay. Now, when I look at this one, I really don't see a clear side that's more complicated. Both sides have a fraction. Both sides have either a 1 plus or a 1 minus. It almost looks like each side is the same, kind of. It's like they're like a mirror image almost. One of them's flipped, the other one has the single trig function in the bottom, the other one has it in the top. So there's not really much advantage here of which side you start with. I would say we've always done the left-hand side, so let's try that. And the goal is to turn the left-hand side into the right. I'll tell you, no matter which side you start with, it's going to be the exact same steps. All right. So if we take that left-hand side, what do we think about changing it to sines and cosines? That's usually a trick we try. Should we try that? Yeah.
We can't because it already is.
It already is. Yeah, so changing to sines and cosines, no, already is. How about common denominator? Do I have 2 separate fractions right there? What do you think, Chad? No. I only have 1 fraction with 1 denominator. Maybe I'll end up with 2 fractions later on as we do the problem, but right now, I only have 1 fraction. So there's one other trick, and we just talked about it in the last problem, that I can try. What's the last trick that I show you you can try? And it involves multiplying. Yep?
The numerator.
We're going to do something with the numerator. We're going to find the what of the numerator? Yep? We're going to find the conjugate and we're going to multiply. Another good reason why it's probably that's the right track is because look at the answer you want to get. It has a 1 plus sign. That's the conjugate of the other one. So by multiplying by the conjugate, you're introducing a 1 plus sign into the problem. That's probably a good thing, because that's the answer that you want to get. So let's try it. 1 plus sign. 1 plus sign. Now remember, when I said when you see a conjugate in the problem, do that first before you do anything else. So if you're thinking, well, is that a distributive property in the bottom? Yep, it sure is. But we're not going to do it. We're going to do the conjugate in the top first, because that's what I said to do. Okay, so always FOIL the conjugate first. Don't do anything else. Leave the bottom just like this. Okay, let's do out the top. All right. Colby, what's 1 times 1 give me? 1. And Lacey, 1 times sign?
2.
And how about 1 times negative sign?
-1.
So those cancel out. So I'm not going to write them. Positive sign, negative sign. Raymond, what's a negative times a positive? It's a negative. And what's sine times sine?
Sine squared.
Sine squared. Okay. 1 minus sine squared. What does that look like? 1 minus sine squared. Yeah,
The first one.
it's the first one. What would you have to do on both sides to get a 1 minus sine squared in the first one? Cassie?
I don't know.
Ava?
Subtract sine squared from both sides.
Yep. Subtract sine squared from both sides. You get that. This would be gone. So what does that formula say now? 1 minus sine squared can be changed into what? Cosine squared. 1 minus sine squared is cosine squared. That's an identity. So let's change that top. Instead of putting 1 minus cosine squared, 1 minus sine squared, change it to cosine squared. Keep the bottom exactly the same. Okay. Is there anything here that the top and the bottom have in common now? James?
Cosine.
Cosine. How many cosines are in the bottom?
1.
How many cosines are in the top? 2. So you can cancel out 1, because they both have 1 in common. Cancel 1 from the bottom. Cancel 1 from the top. And now you're left with cosine over 1 plus sine. That's exactly what you were supposed to get. Cosine over 1 plus sine. I'll just write it nice. All right. Okay, so that's really the last thing that I'm going to show you about trig identities. The only way to really get good at it for the test is to practice. That's why all day tomorrow, it's nothing new. We're just going to practice the ones we've already done. So there'll be a worksheet. I think it's 10 questions. Not as many as the first worksheet because the Pythagorean identities are a little harder. So there's going to be 10 instead of 14. But tonight's homework will be in the book. Now, the first few questions in the book, I think 9 through 14, they tell you what to do. So I kind of led you a little bit and asked you questions, but they're going to do the same thing in 9 through 14 in the homework. They will say, multiply the top and the bottom by the conjugate, or rewrite with a common denominator. Okay, they'll tell you what to do. In 19 through 27, they don't. Okay, 19 through 27, you just have to look at the problem and ask yourself the same questions I asked you. Okay, should we try common denominator? You have to figure out what to try. All right, so under 19 through 27, you can skip 21. Okay, so 21 is something that we didn't talk about. All right, so we'll take a look at that tomorrow. Reminder, I will be after school for extra help tomorrow. And as far as final exams, I don't remember if I told you guys or not, but in full year classes, final exam, midterms are optional. In a half year class, because we don't have a midterm, we only have a final, the final exam is being required. Okay. So that's what was decided. Not like, okay. Does anybody have any question about that? Okay. We'll talk more about that when we get to it, but I just wanted to give you guys a heads up.